On a more specific level, we talked about my model. Again, I'm not trying to defend my model. I'm the first one to say that it has problems.
In 2003, Arvin Board, Alan Guth, and Alexander Vilenkin were able to show that any universe, which is on average in a state of cosmic expansion throughout its history, cannot be infinite in the past, but must have a beginning. In 2012, Vilenkin showed that cosmogonic models, which do not fall under this condition, including Professor Carroll's own model, fail on other grounds to avert the beginning of the universe. Vilenkin concluded none of these scenarios can actually be past eternal. All the evidence we have says that the universe had a beginning. According to Chris Weaver in his article on the Carroll-Chen model, he says the Fari, Guth, and Guven nucleation that Dr. Carroll uses out of a de Sitter spacetime is merely speculative, and Carroll's discussion should be thought of it as exploratory. It is therefore safe to conclude that a central piece of the model is missing, and so the Carroll-Chen model is incomplete in that it does not have a clear recommended dynamical path from the background spacetime to the birth of universes like ours. In fact, Weaver goes on to point out that for a universe described by the Bohr-Guth-Vilenkin theorem like ours, these Fari-Guth-Guven mechanisms cannot produce such a universe, and therefore these mechanisms fail.
He does say that it is speculative, the idea of baby universes coming into existence, the first to agree. It's completely speculative. He quotes a paper that says that the mechanism by which baby universes are created is speculative and might not be right. Again, it's completely true.
Consider now the evidence of thermodynamics. According to the second law of thermodynamics, entropy in a closed system almost never decreases. Given the naturalistic assumption that the universe is a closed system, the second law implies that given enough time, the universe will come to a state of thermodynamic heat death, whether cold or hot. Given that the universe will expand forever, it may never reach a state of equilibrium, but will grow increasingly cold, dark, dilute, and dead. But then the obvious question arises. Why, if the universe has existed forever, is it not now in a cold, dark, dilute, and lifeless state? P.C.W. Davies gives the obvious answer. The universe can't have existed forever. We know there must have been an absolute beginning a finite time ago. The universe's energy, says Davies, was simply put in at the creation as an initial condition. By contrast, Professor Carroll's solution to the problem confronts serious obstacles. He imagines that the overall condition of the universe is a state of thermal equilibrium, a sort of de Sitter space, but that random fluctuations spawn baby universes which pinch off to become wholly independent spacetimes. We find ourselves in one such baby universe in a state of disequilibrium. Let me raise two concerns about this model. First, this model presupposes, the next slide, yes, it presupposes a reductionistic view of time according to which the direction of time is defined in terms of entropy increase. Now, in the model, notice that there are two arrows of time for the mother universe, pointing in opposite directions. So on this view of time, we don't really have an eternally existing mother universe here at all. Rather, you have two universes which share a common origin in the central surface. So what the model actually implies, rather than avoids, is a beginning of time and of the universe. Time has a beginning on this model, and therefore it involves all of the problems that are pertinent to the universe coming into being.
Physicist Peter Bussey writes, "We just have a pair of conjoined normal Big Bang universes back to back. Each has a definite start to its own time scale, and the question of initial causation remains in duplicate. In further proposals, various regions of a complex universe could have many beginnings in time."
Skeptics might hope that quantum cosmology might serve to avert the implications of the second law of thermodynamics. But now, a new singularity theorem formulated by Aaron Wall seems to close the door on that possibility. Wall shows that given the validity of the generalized second law of thermodynamics in quantum cosmology, the universe must have begun to exist, unless, as in Professor Carroll's model, one postulates a reversal of the arrow of time at some point in the past, which, he rightly observes, involves a thermodynamic beginning in time, which would seem to raise the same sorts of philosophical questions that any other sort of beginning in time would. Wall reports that his results require only certain basic concepts so that it is reasonable to believe that the results will hold in a complete theory of quantum gravity.
He spends a lot of time on my own model, more time than I would have spent on it.